Hey everybody, welcome to the first tape lesson on evolution. I hope you guys enjoy it. Today we're going to start talking about natural selection and how natural selection is a mechanism for evolution. So evolution, we define it as something that includes all the changes in the characteristics and diversity of life that occur throughout time. So we're looking at all the different changes in organisms and their diversity throughout life's existence. So, this concept of evolution has been talked about, discussed for a very long period of time, way before Darwin even. However, it was hard to really pinpoint a mechanism for what drove evolution to happen. Um, so that was kind of the missing piece to this whole problem. We believe that these kind of things happen, but we didn't really know why they happened. So that's when Darwin came around, and he went ahead and took his journey throughout the world. He traveled for about 5 years by sea, and went around the world and looked at all the diversity of life. And through all of his observations, he kind of came up with this theory of natural selection, which we're going to talk about today. So, a few things that natural selection basically says, the rules to natural selection. In any population organism, there is natural variation. So that's kind of obvious, right? So we look around us, all humans are all different. We all vary in various ways. So that's kind of one of the main rules that kind of apply to natural selection, and one of the things that Darwin noticed. So some of these variations will allow organisms possessing them to survive and reproduce better than those without those particular traits. So that's the kind of the driving force of it. So these variations, because they're different, somebody's going to have an advantage. And once you have that advantage, you obviously can survive better and also reproduce better, theoretically. So because of those two things, a lot of times that those traits will be passed on to further generations, because those traits are what is driving reproduction. So again, those traits will be spread throughout the population, and that change in frequency of the alleles, the traits, in the population, what evolution is. So again, we have this trait. It's favorable towards that organism, or towards that particular individual, and he has an advantage. He or she has an advantage, and so that allows them to survive longer, reproduce more. They have more babies. Their babies have an advantage now. They go ahead and survive longer, reproduce more, and soon enough, this population has now changed because that trait has now dominated that population. Okay, so a few more rules to natural selection. Darwin also noticed that organisms have potential for high fertility. So if given the ability, organisms will reproduce in very large numbers, or as many as they can. But again, he saw that happening, but to counter that, he also saw that a lot of these populations stayed constant, which means a lot of the offspring did not survive for whatever reason. So he kind of looked into that, what that might mean when he looks at the population. Like I said before, Darwin noticed that the populations remain constant. So you don't really see much fluctuations. You see small ones every once in a while, but for the most part, that population stays the same if untouched. Another rule to natural selection is that Darwin noticed is that there is always limited resources. So these organisms, these living things that he observed, always were in a place where they had limited amounts of food, water, shelter, nesting sites. So these scenarios, they're limited, and that limitation of these resources creates competition. And so that competition is kind of what causes these certain traits to flourish, because they give them advantage, and because that advantage gives them the ability to gather those resources better than others, they survive longer, they reproduce more. So again, going back, we said that populations want to reproduce. They want to reproduce. However, they have limited resources, and because they have limited resources, there will be competition. And so have competition. Now we already established that populations vary, and so because they're not all the same, there's competition, there are going to be winners and there's going to be losers. And those winners win because they have some type of variation that gives them advantage, whatever it may be. And obviously that varies throughout every circumstance. But there's always winners and losers, traits that are favorable and unfavorable because of the competition. And another rule to natural selection is the idea that variation has to be heritable, meaning it has to be able to pass down from one generation to the next. So theoretically, if you wore camouflage, you're an organism that got put in camouflage, painted camouflage on you, and you gave you an advantage. Yes, you could survive longer, and yes, you could gather those resources better. But when you reproduce, that camouflage would not be passed on. So that's the idea. And obviously, some of these traits enhance survival, and because they enhance survival, you can reproduce more, and because you reproduce more, those traits are passed on more often. So this would be a scenario here of natural selection happening. So here we have variation within the mice, right? Different colored mice. One color is similar to the color of the ground, the other stands out more, the white color. And so right now they're even, same amount. But then we enter in predator. Now obviously we look at the predator. Predator is going to pick out the easiest prey. And in this case, the easiest prey to see would be the white mice. The camouflage mice, it's harder to see, and so why would the hawk trouble with those guys when you can easily see the white mice better? And so over time, these white mice are going to dwindle. And because the camouflage trait, the camouflage mouse, hair color, is favorable. And so the white mouse will start to dwindle and dwindle and dwindle in size, whereas the camouflage mice will survive better. And so that, again, these traits give individuals an advantage, and over time that advantage is passed on through the entire generation. So if we looked 50 years down the road, this population of mice would more than likely be entirely camouflaged. So the favorite traits will spread throughout the population. Over many generations, the species will become adapted to its environment. Again, because those traits give it the best advantage, and that advantage is geared towards its environment, its predators, its resources, and so over time, that population becomes adapted to its environment. Now, of course, these adaptations could change in response to environmental pressures. A famous story that we'll talk more about in class is with these moths in London back in the 1800s, in the Industrial Revolution, where there's lots of pollution, lots of soot that got produced, and that soot would settle on trees and make them a darker color. So before the soot, before the pollution, you had dark moths and light-colored moths, and but as soon as the pollution started to build up, you saw that white moths almost were completely eradicated because they stood out so well in the dark trees because they were light colored, whereas the dark moths dominated. And we saw this complete population change over a matter of a few years, where the entire population of moths were all dark colored. So again, that's any kind of change to the environment will more than likely affect the population in that environment. So When environment changes or when individuals move to a new environment, natural selection may result in adaptation to new conditions. And sometimes these result in new species. We'll talk more about this in class when we talk about what Darwin saw on the Galapagos Islands and how these islands were all separate from each other, and he saw that you had one species that came over from South America, and then eventually that species of bird, the finch, evolved to their particular environment on that island. And so they all became different in different ways to be more successful in the environment that they were in. Another idea, keep in mind, and again, a lot of this evolution we're talking about, these are ideas that drive this idea or this mechanism for evolution, which is natural selection. So the way you're kind of looking at this, you're painting a picture to what creates this idea of natural selection, these rules to natural selection. So another idea to this is that populations evolve. Individuals do not evolve. So all of you listening to this, none of you are going to evolve. However, the human population over a course of 10, 50, 100, 1,000 years does evolve in various ways. So, but we never look at individuals because they do not ever evolve individually. So, to conclude, a couple important points. Like I said, natural selection can only work in heritable traits, so it must be able to be passed on. Otherwise, it doesn't change the population at all. And also that it's never random. Natural selection never randomly happens. It's always in response to some kind of environmental pressure, and so it just doesn't randomly happen. There has to be environmental pressure to push that change. And so that's it, guys. Hope you enjoyed it. Again, you can go back and look at this again. We'll talk more about it in class, but I hope you guys enjoyed it. Quick 12 minutes. Thank you so much. I'll see you tomorrow.